In an Eden rolled comparator, the mechanical lever is 150 mm long and is mounted on parallel strips 4.4 mm apart. Compute the overall magnification of the comparator if the optical magnification of the movement of the end of the lever is 50. So here the mechanical magnification is given by L by delta, where L is the length of the lever, so it is 150 mm, and here delta is 0.4 mm, so which gives a value of 375, and here the optical magnification is 50, so that overall magnification is 375 into 50, which is equal to 18,750. So right option is D. How is to be transmitted through 0.3 meter diameter 500 meter long pipe fitted with a nozzle at the end. The inlet is from a reservoir where water level is 90 meter above the nozzle. So here take F is equal to 0.03. The maximum power which can be transmitted is, and here the second question is the diameter of nozzle required is. So coming to solution, the maximum power which can be transmitted is, it is the first question. So to transmit the maximum power, the HF or head loss should be equal to the 1/3 of the total head available. Here the total head available is equal to 90 meters, so it is equal to 30 meters. Now the power transmitted is equal to gamma into Q into H minus HF, where gamma is the specific weight of the water and here Q is the discharge and H minus HF is the difference between total available head and head loss due to friction. And here HF is given by FLQ square by 12.1 d power of 5. So by using this equation we can find out the discharge. Here F is the friction factor and L is the length of the pipe and D is the diameter of the pipe. So all the values are known values, and from this we can find out H, that is equal to 0.245 meter cube per second. So now the maximum power transmitted is equal to gamma Q, that is here gamma for water is 9810 and Q is 0.245 and H minus HF is 90 minus 30. So it gives a value of 142.7 kilowatts. So in option, the right option is C. C is the right answer for the first question. And coming to the second question, we will have to find out the diameter of the nozzle. Here diameter of the nozzle is given by 4th root of d power of 5 by 2FL. So which is equal to 4th root of 0.3 power of 5 2 into 0.08 into 500 meters. So it gives a value of 0.0949 meters or 9.49 centimeters. So in option, the right option is B. B is the right answer. A job shop incurs a cost of 60 rupees per day for each day a job in the shop. At the beginning of a month, there are 4 jobs in the shop with the following data. Here jobs are A, B, C, D and processing time is 5 in days 5, 3, 8 and 2. Due date is 10, 12, 20 and 9. So here it is a common data question. It consists 2 questions here. The first question is the best sequence as per the least slack rule is, and here the second question is the minimum total cost is. Here least slack rule, in least slack rule, least slack is equal to due date minus processing date. That is, for the job A it is 5, for the job B it is 9, and for the job C it is 12, and for the job D it is 7. So here by using least slack rule, the best sequence is here we'll have to go with increasing order. That is, here A has the least slack, the lowest least slack, and next D, and next B, and next C. So that ADBC is the best one, and in the option the right option is B. And the second question is the minimum total cost is. Here minimum total cost is equal to the total processing time for any sequence. So that is, the total time for any sequence is 5 plus 3 plus 8 plus 2. So that the minimum total cost is here 5 plus 3 plus 8 plus 2 into per each day 60 rupees it costs, so that it is equal to 60. So which gives a value of 1080 rupees. So in the options, the right option is B. A weight of 2 kN drops through 40 mm at the center of 300 mm long simply supported beam. The beam made of steel of square cross section has yield strength of 501 per mm square and the factor of safety is 2. The Young's modulus of the steel is 200 gigapascal. Here it is a linked answer question. It consists two questions in such a way that second question answer depends on the first question. Here the first question is determine the dimensions of side of cross section of the beam. And here the second question is maximum deflection of the beam if the same load acting as static load at the midpoint of the beam is. Coming to the solution, here in the given problem, a weight of 2 kilonewtons drops through 40 mm at the center of the simply supported beam. So that means here simply supported beam is subjected to an impact load. So we know that here the impact stress is given by W by A into 1 plus root of 1 plus 2 HAE by WL, or we can write it as it is sigma. W by A is nothing but the static stress induced in the beam, that is sigma S 1 plus root of 1 plus 2H by WL by A is nothing but static deflection. So we can write this equation like this. So here the static stress induced in the beam is equal to the maximum bending moment by section modulus. Here the maximum bending moment for a simply supported beam subjected to a load at the midpoint is WL by 4 into Z. So here it is equal to Z is equal here let us say A is the side of the cross section of the beam, so that here WL by 4 into Z is nothing but A cube by 6. So which gives 3 by 2 into WL by A cube. Here W and L are the known values. W is 2 kilonewton and L is 300 mm. Now substitute all these values in this equation. So which gives 9 into 10 power of 5 by A cube. So this is the static stress induced in the beam. And now static deflection is equal to when a simply supported beam subjected to a point load at the midpoint at center of the beam. So then static deflection is equal to WL cube by 48 EI. So which is equal to 2000 into 300 cube into 12 by 48 into E is 2 into 10 power of 5 and I is nothing but area moment of inertia, it is A power of 4 by 12. So here which gives 67,500 by A power of 4. So these are the static stress induced in the beam and static deflection induced in the beam. Now substitute these values in the impact stress equation, and impact stress is not to exceed the maximum yield strength to factor of safety. So here maximum yield strength is 500 and factor of safety is 2, so that it is 250 megapascal. Now substitute all these values in the impact stress equation, that is sigma I is equal to sigma S into 1 plus 2 plus root of 1 plus 2H by del S. So on the substitution of this equation, on the solving of this equation, we can get the value of A. So now here the value of A is equal to 124 mm. So this is the side of the cross section of the beam. So in the given option, the right option is C. Now coming to the second question, the maximum deflection of the beam if the same load acting as static load at the center of the beam. So here if the same load acting as a static load at the center of the beam, then sigma S is equal to, sorry, here we'll have to find out the deflection, so that del S is equal to 67,000 by 500 by A to the power of 4, that is 124 power of 4, which is equal to 2.8 into 10 power of minus 4 mm. So in the option, the right option is A. A is the right answer.